Good morning, class. In this, we will continue our topic, that is evaporation, and we were doing effects of evaporation and how the evaporation is affected by the different causes. The first is the effect of temperature on the rate of evaporation. So we very well know that more will be the rate of temperature, more will be the temperature. That is, if there is increase in temperature, the rate of evaporation will also be more. For example, if we take sunny days, that is the month of summer, hot summer days, the water evaporates faster from lakes and rivers, but in winter the process is very slow. The effect of blowing air also increases the rate of evaporation. If the air blows faster, the rate of evaporation will also be faster. The next is the effect of increase in area. For example, if you take a larger area, the rate of evaporation will be more, and if you take a small container, the rate of area will be less. For example, if you take water in a big tub, the rate of evaporation will be more, and if you take that water in a bucket, the rate of evaporation will slow down. The next is the effect of presence of humidity. The more if the humidity will be present, that is more humid, during the more humid days, the rate of evaporation is very slow. The next is the cooling produced by evaporation. So we have already done this, that the cooling is produced during evaporation, and we have seen some application, that is water taken in the earthen pots cools. The water inside the earthen pot is very cool. If we stand under the fan after taking bath, we feel cooler. That is because of the evaporation. The next is the boiling also we know about boiling, that boiling is the change of liquid to vapor at a constant temperature, that is 100 degrees Celsius. That is called boiling. This is the activity which is shown. They have taken a beaker full of water, and this beaker is kept on the wire gauge, and the heat is given from tripod stand. Burner is kept, and the thermometer is placed on the top of the water. Now what we can see is the water, as soon as we supply heat, there is a motion in the water, and this motion changes to kinetic energy, and we see bubbles, faster moving bubbles moving upward, and this bubble shows that the water started boiling up at 100 degrees Celsius. Now next one is the explanation of boiling on by the molecular motion. Now when we supply heat to the body, when we supply heat to water body, then what happens? We see bubbles, and this bubble is the example of the kinetic energy which take place inside the water, which is written in your book, that heating of the liquid increase the average kinetic energy of the liquid molecules, and when the molecules acquire sufficient kinetic energy to do work against the force of attraction of the other molecules. Now we also know that there is a force of attraction in liquid molecules, and this kinetic energy does the work against this force of attraction. Now these molecules now start leaving the liquid, not only the surface but also the walls of the containing vessel, and this shown by the presence of bubbles on the walls of the vessels, and the bubbles grows in size with further evaporation and move to the surface in quick succession. This causes agitation in the whole liquid, and this is called boiling. We have already understood about this in the previous activity, that bubbles shows that there is a boiling has taken place. Now the effect of pressure on the boiling. Now boiling point of the liquid increases with increase in pressure and decreases it decrease in pressure, and that is why in mountainous area where the pressure is low, the water boils below 100 degrees Celsius, and that is why vegetables are not cooked properly. But if we just lower this pressure and keep the things in the pressure cooker, the things get boiled properly, because the pressure is increased inside the pressure cooker, and that is why the things get cooked faster. Now, difference between evaporation and boiling. This is also we have done in the previous chapter. Difference in evaporation and boiling. Now, evaporation take place at all temperatures, while boiling take place at a fixed temperature, that is 100 degrees Celsius. Evaporation occurs only from the surface, but boiling take place in whole of the liquid. Now, in evaporation, some molecules near the surface of liquid acquire sufficient kinetic energy by collision with other liquid molecules to overcome the attractive force of the other molecules. But what happens in boiling? That in boiling at a fixed temperature, the average kinetic energy of the liquid molecules becomes sufficient to overcome the force of attraction of the other molecules, and they start leaving the liquid. They, in this condition, the molecules leave the liquid, but in evaporation this phenomena is not seen. The next is the in evaporation, heat is absorbed by the molecules at the surface of the liquid from its surrounding so as to change into vapor state, while in boiling the heat is supplied externally at a fixed temperature. In this, the heat is given, and in this condition heat is absorbed, but in this condition the external we give the heat externally. Now, evaporation is very slow process, and on the other hand, because heat is given to this boiling, so boiling is a rapid or very fast process. The next part is the thermal expansion, and there are thermal expansion. Thermal, student, from the word only we can understand that thermal means heat, and thermal means heat. Thermal means heat, and in heat, an expansion means something which expands. So it has been experimentally observed that when a substance, it can be solid, liquid or gas, when it is heated it expands, and when it is cooled it contracts. So we have many application for thermal expansion, and thermal expansion is seen in solids, thermal expansion is seen in liquids, and thermal expansion is seen in gases as well. Now these are some exceptions of thermal expansions, that is water from 0 to 4 degrees Celsius, water from 0 to 4 degrees Celsius, and silver iodine from 80 degree to 141 degrees Celsius, silica below 80 degrees Celsius. What happens? These are exceptions, and the exception is that they contract on heating and expands on cooling. So these are the exceptions. It can be asked to you in your examination. The next is there are many applications which proves the thermal expansion, and the first one is the ball. This ball which passes from the ring in winters, but in summers it has been seen that because there is expansion in this ball, this iron ball do not pass through this ring because of the expansion in the in this spherical ball, and because of this expansion it cannot pass through this ring. But in winters this iron ball contracts, and this is able to pass through the ring easily. And there are many more. The next is this bar and gauge setup to show the thermal expansion. The next is the next part is the linear expansion. Linear expansion, that is expansion which is seen in lengthwise expansion is seen. For example, length of the rod or something which is in linear or straight form. The next part is the cubical expansion and the areal expansion, that is the superficial expansion seen in area wise, and expansion seen in cubical wise, that is in solids. So we have many examples. We are most concerned with the cubical expansion of solid, and for this we are having many examples, many application given in the book. The first one is the grider gap. In a bridge, one end of the grider gap is kept on the roller for expansion or contraction. We will go through this in the next part of the video, and we will also understand why the gaps given between the railway tracks. The next one is the riveting, and why this type of bulge is seen during summer season in the telephone wires, and this type of straightening is seen in winter season. And there are many other steel rim fitted over the wooden wheel, and there are many other application and example given in your book. Glassware used in kitchen, pendulum of a clock made up of invar, loosening of glass stopper or a metal screw cap, and cracking of thick glass tumbler. So we will see the reason why these all things happen in the next part of the video. Till then, you go through this video which has been done, and assignment will be given to you related to it.